Greetings and welcome, internet friends. We were talking about like parallel lines cut by a transversal and different things that we were able to conclude regarding the angles formed by that graphical diagram, I guess. And notice that lines are marked parallel when they have little arrows like such. If there was like another set of parallel lines that weren't parallel to the first, then you could have like double arrows or triple arrows to label those like so. So here it asks us to find the measure of angle 1 and the measure of angle 2. How, my friends? Let's see. Ooh, I've got my cards here. I could draw my cards. I'll only draw those for those of us who were here yesterday. Ryan. Aha. How might I find angle 1, or how do you think angle 1 relates to the 150? It just is. The lines are parallel. Oh. So this is corresponding angles theorem, is what Ryan was saying. And angle 1 is going to be congruent to this, and therefore, by def of Kong, their measures are the same. How about this one for an easy go? Liam, how could I get from 1 to 2? From the cat to the vat. Did I tell you guys the cat vat story? Oh, that's a good one. We'll save that one for after this video. It's a little bit disturbing. Another way. Does anyone see an other way that I could jump from 150 straight to the 2? I just realized my inkwell isn't here. 8. Which, for those of us who weren't here, what does that stand for? Alternate exterior angles theorem, right? I like it. Beautiful, beautiful. So that's a way you could jump right to there from there. Which, by the way, if I had a choice, I would try to relate this to the given information, if possible, rather than relating it to information that I found. In case, what if I made a mistake on angle 1? And now my mistake is spreading throughout the rest of the problem like some sort of plague. So the more I can relate it back to the beginning, the potentially safer I am in my assumptions and work. But no worries, no worries. I'm fully justified here. I like it. Okay, let's see. How about 6 here? Emmett, what are you thinking about number 6? Postulate, LPP, yeah, you know me. Linear pairs are supplementary. There'd be a little bit more work there. You'd say measure of angle 2 plus 140 equals 180 by LPP. Then I'd subtract 140 from both sides using subtraction property of equality. There you go. How about measure of angle 1? Let's see, Holden. Not Holly, by any means. What do you think? 140? That's what this little arrow means. Those lines be parallel. I like it. Hey. Or he's just asking to inform the audience, to invite them into the experience. And 140 and 1 are the same. These two angles are congruent. Does anyone know why? I'd buy that. Alternate interior angles theorem. Also, I could have related angles 1 and 2 using the consecutive interior angles theorem, and these two would be supplementary and blah, blah, blah. So, there you go. Let's keep going. Let's keep going. All right. Find the value of x. Show your steps. All right. If this is 65, what's this number 5 angle going to be? All right, 65 by corresponding angles theorem, which I might still call CAP some days. Yeah, definitely remind me to tell the cat vat story. It's disturbing. And so if this is 65, it looks like these two, Emmett would tell us, is a linear pair, right? And therefore, linear pairs are supplementary, so 11x plus that 65-degree angle is 180. And I think I could combine some like terms. The 17 and the 65. Oh man, they're asking me to do math? Guys, doing math, like, with other people watching, it sometimes makes me a little nervous. Like, when I have to calculate the tip when I'm at a restaurant, I'm just like, I'm not being paid to do math right now. I'm nervous, like, ugh. And then I just round up. I just triple the bill and, yeah, that's the thing. And then round up, like, another, I don't know. So let's see, 11x, 65 minus 17, 65 minus 10, 15 would have been 50 minus another 2, 48. Did I do that right? Who knows? Literally no one knows, actually. No one knows if I did that right. And then classic subtraction property of equality, subtract the 48. Right, this is the stuff where you guys are just like, algebra friend. And what's this going to be? 132. Is that divisible by 11? That feels like it could be. It's 12? Wow. So I get x equals 12. And fortunately, using the division property of equality, right? And fortunately, they didn't ask us to find out angle measures. They just were like, what's x? And that's great. Nice and easy. Ooh. Wow. I'm excited about this one. You guys were pumped about this one. Okay. All right. So if they want us to prove the alternate exterior angles theorem, let's see if I can draw a picture that's going to help us. All right, so I'm going to have, like, what is the hypothesis of the alternate exterior angles theorem? It would be that I start with two parallel lines cut by a transversal, right? Let's call this angle 1, maybe this angle 2, and this angle 3. So I'm just, like, making up names that apply in general situations. I think you'd agree, Ryan, right? Like, I haven't assumed anything too crazy here just yet. So these two lines are parallel. Oh, we could even give them names. I'm going to call, you know what? I'm going to call this L for Liam and R for Ryan. I don't know how to do, is that like... Yeah, you're never gonna meet. Never gonna meet. Boy, I think you should tell geometrically based romance stories, and the transversal's just like friends with both of you, I guess. But doesn't hang around for long. Oh, what's its name? I don't know. What's a good name? J for Josh, and he's yellow. So let's see. So starting information, L is parallel to R. Guys, I don't think I made a cursive R in literally 20 years. No, that's a lowercase r, isn't it? Ask anyone on the internet. I thought M was like this one. I think he just called me boy. Given is why that's true. That's what I'm doing, right? Oh, my slope needs to be like that-ish? And what? I thought it had like a little bit of concavity. All right. Well, someone please in the comments below link me to some cursive YouTube channels so that way I can learn cursive all over again. All right. I'm going to say angle 1 is congruent to angle 2. Why is that true? Yeah, corresponding angles theorem. When I'm proving these other theorems, I'm assuming cat has already been proven. I think I could then say angle 2 is congruent to angle 3. The cat in the vat. That's right. I actually was checking out some Cat in the Hat memes last night when I was on the internet. I didn't know it was a thing, but now I do. And then I think I can now say that angle 1 is congruent to angle 3. Looks like some sort of transitive property of congruence. If 1 to 2 and 2 to 3, then 1 to 3. And I think that's what I set out to prove with alternate exterior angles being congruent. Lovely. Wow. Substitution property of congruence doesn't actually exist. I've definitely had a low standard, and I've allowed it sometimes, but then, like, the other accelerated geometry teacher was just like, and I'm like, oh, uh-oh, and... Not with congruence, yeah. But there is a transitive... No, I agree. Maybe you could make the Ryan theorem and just, like, prove that works somehow. Or maybe you'll find some contradiction there. I don't know. All right, here's 24. I'm going to verbally explain this one, okay? So just track with me here. In the diagram, angle 4 is congruent to angle 5. Oh, man, we're going to be able to prove so much stuff about that someday. But not this day. And SE bisects RSF. RSF. So that means, by definition of angle bisector, those two are congruent. Do you agree? You with me here? Yeah? Meow, 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 meow. Okay. So I'm also recognizing that SE behaves as a transversal between these parallel lines given, right? You guys see that? I think I could say that angle 2 is congruent to angle 4. How? Alternate interior angles theorem. Yeah, angle 2 is congruent to 4. And that means, these are congruent as well by transitivity. So right now, all 4 of these are congruent. What's angle 1's story? To 3? Those aren't quite vertical angles. 5. How's it congruent to 5? Oh. Yeah, those are corresponding angles. Corresponding angles theorem. And so 1 is congruent to 5. If these 3 are all congruent to each other, then their measures are by def of Kong, right? They're equal. And if those also all form a straight angle, that straight angle theorem that keeps getting pitched my way, they add up to 180. And so you could call 3 times the measure of angle 1 equals 180. And what is the measure of angle 1 going to equal? 60. Okay, yeah. Once we proved that 3 was congruent to those, you're right. All these form a triangle, and you're, I know we know this, but we don't know that we know that the sum of the interior angles of any triangle adds to 180 degrees. I don't think we've proven that yet. The trisum theorem, as will be proven later by us. But you're right, because all of these add up to 180, and those were all 3 the same, those all would have been 60, and yeah. So you're right. That's another strategy. I like it. You've proven it. When they happen to all be the same. We know in the case of when it's 60, 60, 60, now that they add up to 180, but does it work when they're not all 60? Yeah. But anyways, thanks for watching, internet friends. Have a great day.